following, we are going to present you one of the OConS mechanism as example. So the flow management mechanism, which is a very important mechanism in order to manage and control the application flows for a multi-home user in a heterogeneous network environment. So usually the flow management problem combines the problem of access network selection, which means how we select the appropriate access networks for delivering the application flows, and the flow distribution problem, which mainly to dealing with how we distribute or schedule the application flows among the selected access networks. So in the following, I will firstly give you a general introduction of the flow management mechanism and what has been done in this area. And then we will show you as well different flow management mechanisms which has been proposed and investigated in the SAIL project. And as an example, I will present in detail the user-centric flow management approach, which I'm mainly working on. And for this part, we're trying to formulate the flow management problem as linear programming technique, and we evaluate in a simulation environment. So in this talk, I'm also going to show you some of the first results we get from the investigations. So in addition to the scientific analysis and evaluation, we are also focusing on the prototyping and implementation of the access selection of flow management mechanism in the framework of OConS. So we will show you some of the example later. And at the end, we also would like to have an open discussion with everyone of here to talk about this topic. So why do we need flow management? Where is the motivation? So nowadays, with the evolution of the wireless technology, there are more and more wireless access networks of different types being deployed by the network operator. And often they are overlapped in the same coverage areas. So imagine if you are in an airport or train station, you have a smartphone, you can connect to a Wi-Fi hotspot, or you have the 2G or 3G connection, or possibly you can have a LTE or wireless connection. So all different wireless technology allows us or create us a heterogeneous wireless network environment for the mobile users. On the other hand, there's fast development of the end devices of the user. For example, nowadays the smartphones or iPads, such devices are able to support multiple interfaces, which allows us to connect to more than one radio access technologies to use them simultaneously. So with such changes, we have the availability of a number of access network and a number of the interfaces per user device. So we're facing now the challenge as well as the problem about how we select and use the most appropriate access networks, which could be one or could be also more than one of such networks, in order to provide the always best connected services. And in this context, we will need a proper flow management mechanism for the multi-home mobile device. So now we can define the flow management problem as two sub-problems. So firstly, the network selection means giving available multiple access networks, how you define the criteria to choose the best or most suitable access networks. The second problem is the flow distribution. So that means once you have chosen a number of the access network, so how are you going to distribute the application flows over these selected access networks? So as an example here, this user device could have two application flow. One is HTTP, one is the FTP. So in such a network scenario, the user could have two possible access networks. One is via the Ethernet, and one is via wireless LAN. So the flow management can make the decision whether I'm going to distribute these two application flows over two different access networks. So that's the task of the flow management. In general, we can define 4 different means or options to distribute the application flows over the selected network path. So the first method is straightforward, just how to distribute the application flows. So, in example, if the user has 2 access networks, the question is how we can distribute the different application flow over these 2 different access networks. The second option is to split the flow. Means given one single traffic flow, whether we can distribute or split this flow over different or multiple access networks. So by doing it, we can have the aggregate bandwidth, and then we can increase the overall transmission throughput. The third option is to doing end casting of a flow, which means that I can also choose to multicast one flow over the multiple connections. So this will be very helpful in the situation that the user is able to connect multiple connections with of the same access technology, but with very high error rates. So by doing multicasting of the flow, the mobile node is able to receive the same traffic over multiple connections, and then we will have the redundancy, or provide the redundancy of the network in order to reduce the overall transmission error. So the last option is the flow dropping. This will be very useful in the situation where the mobile node has very limited bandwidth resources. In order to avoid the further congestion in such a network situation, the mobile node can ask for the home network to stop sending further the flows, and in this means by dropping this flow. So these are mainly the 4 different options you can use for the flow management, and depending on the situation and criteria, you can choose one of the methods to be used. So in general, when we design the flow management approach, we can classify them into 3 main different classes. The first one is to have a network-centric approach. Means when we design the flow management, is mainly from the network point of view. It's network-based. So the objective is rather to improve the network performance. For example, to increase the network quality of service, or to enhance the resource utilization. So for this approach, we're choosing the criteria, for example, the more related to the network performance. And a lot of related work has been using the network quality of service as the main criteria for doing the load balancing among the available networks. The second class of the flow management approach is the user-centric approach, which is, by the name, you can think about that the approach is mainly to do the flow management to consider the user-relevant criteria, and also the use-based approach. With this approach, the objective is mainly to improve the end user's performances, and the most common criteria could be the application quality, the price of the network, and the power consumption or user preferences. And in this work, they propose a user-centric, quality-aware multi-home flow management, and this also I'm going to present in detail later in this talk. So the last class is to maybe combine both network-centric approach and user-centric approach. So by doing that, we can consider both the network and user-related criteria, and finally we can try to do the trade-off of the performance for the user as well for the network. So when we implement the flow management, we need to firstly think about what kind of research problems that we're dealing with. So since the flow management is considered a problem of network selection and flow distribution, so firstly we have to think about the criteria to choose the most suitable access networks. So what are the criteria you're going to focus on? And in order to make a decision about flow management, so what kind of parameters or informations you need to collect from the network or from the users? And the sub-question is, who is going to make the decision for the flow management? Whether it's a user, or whether it's a network, or whether someone else. And by designing the flow management, we also need to think in advance what could be the gain you're expecting by using the flow management. Whether you're aiming for more throughput or try to reduce the cost, or you are aiming for improved user performance. So these are relevant to the criteria of the network selections. In addition, when we implement the flow management mechanism or designing flow management mechanism, we also need to pay attention to the work of the relevant standardization bodies. For example, like 3GPP or IETF, they are also making effort on the flow management in terms of like how to integrate different access technologies, and how to provide the mobility management, and how to select access networks. And after all, we also will require a general architecture for a heterogeneous wireless network environment in order to deploy the flow management mechanism. So these are all the problems you need to think about by designing the flow management approach. So to summarize some of the facts, so for a flow management, we will require to take into consideration the following aspect. Firstly, how we do the network selection, and then how we distribute the application flows, whether we are doing the flow distribution or flow splitting or doing the load balancing. And to realize the flow management, we also require the technology of multi-homing, the support of mobility management, and in addition, we require an architecture who is able to integrate different multiple access technologies. And for business scenarios, when we design the flow management, we need to think about whether you want to go for the network-centric, the user-centric, or a hybrid approach. So in the following, I will give you more detail about the state of the art in the area of architecture, the multi-homing mobility management technologies, and some of the related work which has been done in the network selection. So the 3GPP standardization has defined evolved packet core architecture in order to integrate the 3GPP system with non-3GPP access technologies. For example, you can see here the mobile node, which has the possibility to connect to 3GPP systems, for example, the 2G, 3G, or the LTE technology. And on the other hand, it also has the possibility to connect to the non-3GPP system, for example, the WiMAX or a wireless LAN technology, and they are merged or integrated at the core network located at the PDN gateway. So such an architecture allows the mobile nodes to have a multi-homing by utilizing all the different access technologies. So with this architecture, we also need to dealing with the problem of mobility management. Mobility management is usually needed to deliver seamless services between different radio access networks. For example, in such a system, if you want to switch between the 3GPP system to the non-3GPP system, then you will require the mobility management functions. So here you need to take notice that the mobility management does not equal to the flow management, because the mobility management is only dealing with the function of or issues with the mobility. However, the flow management does not require the user to be moving around. So it can be a fixed user which have multiple access connections, and it still needs the function of how to distribute flows by utilizing all the available access networks. So in this case, we should keep in mind that mobility management does not equal to flow management, but on the other way around, the flow management will require the support of mobility management in case the user is moving. So in the literature in the past, there have been a lot of research done in the area of the mobility management, and there are different classifications of the mobility management functions. One of the important aspects of mobility management is on which layer the mobility management is handled. So in principle, the mobility management can be handled at the data link layer, which is mainly for only using a single radio access technology. And when you have multiple access technology, the most popular approach is to do the mobility management over the network layer. So there are mainly by, for example, mobile IP version 4, mobile IPv6, and inside the mobile IPv6, they also have different extensions. For example, the proxy mobile IP or the mobile IP supporting multiple care of address, which also called the multi-home mobile IP. So these are the main technologies we can use nowadays to support the mobility management in cases of dealing with the different access technologies. In addition, the mobility management could be also provided at the transport layer, for example, by using the SCTP protocol, or handled at the application layer by using the SIP protocols. The other classification of mobility management function can be based on like who make the decision of the handovers. Could be also user-based or host-based or network-based. Furthermore, we can also classify the mobility management function based on how we trigger or handle the handoff algorithm. Could be proactive management approach or reactive handoff management approach. And there are also a lot of studies carried out to discuss the mobility management using cross-layer solutions. So, for example, a lot of proposals have been made to suggesting the combination of using mobile IP, which is handle the mobility over the network layer, with the SIP protocol, which is handling the mobility over the application layer. So there are also much more classifications of mobility management, but these are the main categories of the mobility management functions. Okay, so in addition to the mobility management, which is required for supporting flow management, we also need to know the multi-homing. So what does mean multi-homing? As you can see in this picture that in such a mobile environment, the mobile node, which is able to connect to the, for example, the remote video server over the internet by two different paths, which is provided by two different internet service providers. And typically, these two different networks or paths will have different quality of services. So the multi-homing solution is actually providing the user to utilize these two links in parallel. And that's the intention of multi-homing. The motivation here actually, at first, it will provide the link redundancy in case of one of the link fails, and you can using the other link. But also, you can use multi-homing to optimize use of the available access links in order to improve the overall network performance in terms of you have a higher throughput because you can have the bandwidth aggregate when you're using the bandwidth of both connections. So that's the main reason we are using the multi-homing, and accordingly, the multi-homing will define the functionalities to handle the failure and the session survivability and the traffic engineering in terms of load sharing or load balancing. So here you can see an example of using multi-homing with the mobile IPv6. So here you can see the mobile node is communicating with the peer communication node, which is also called corresponding node, via two different paths. One path is over the mobile network by connecting the mobile node with the base station. The other path is by a wireless LAN by connecting the mobile node with the wireless LAN access point. And in this case, the mobile node will have firstly a home address, which is assigned by the home network. And in addition, for individual access network, it will also have its own key of address. So in this example, the mobile node will have two key of address and one home address. And with this, the home agent is going to do the association between the home address and with the key of address, and to provide the communication using these two paths, we will have establish the tunnel between the mobile node to the home agent. So the multi-home solution enables the mobile node to use these two paths in parallel, or in some cases can also switch between these two paths to transmit the traffic. Okay, so now we know about the mobility management, we know about the multi-homing technology, and now how we do the network selection. The network selection also has been studied extensively, which is aiming to select best access network in order to satisfy the objective of always best connected for the user. And there have been also different studies made in this area. So as we want to study the network selection, firstly we have different criteria about how to select the best access network. So there are some studies to choose the criteria based on the quality of service of the available networks. And there are also some studies choosing to consider the user's quality of experience. And there are also a few studies which are also looking at the user-centric criteria in terms of the power consumption, of the cost of the using certain access network, and there are also some few studies looking at some predefined policies by the network or the user, and the user defined preferences. So when we have a case of multi-criteria need to be considered. And in this case, they also have several studies and work to trying to using the multi-objective optimization method in order to select the best suitable access networks. So, for example, some studies are using the analytical hierarchy process to rank the different criterions, and then in terms of multi-criteria, and when they are ranking with this method, then you can choose the best access network accordingly. And there are also some studies are using a more heuristic approach. For example, the genetic algorithm or fuzzy logic-based decisions. And some of this work also formulate the network selection problem as, for example, the bin packing problem or knapsack problem, and which are more using more mathematic methods to formulate the problem and to solve it, to give a suboptimal solutions. Okay, this is a more overview about what has been done in this area. And in addition, as a second line of the work, and there are also a lot of effort contributed by the standardizations in the area of network selection. So, for example, the IEEE 2.2011 group, they also define a media-independent hangover framework to do the discovery and selection of wireless access networks. And by using that, they try to provide seamless hangover between the IEEE system with the non-IEEE system, for example, the cellular networks. In addition, the 3GPP also has made some work in the area of access selection, and they define access network discovery and selection function in the architecture in the release A. And they try to using this function to provide the access network discovery and selection assistance to the mobile nodes. And the IETF actually also trying to support both of the functionalities by introducing the discovery mechanism, for example, using the DHCP solution or the DNS solution. Okay, so that's a very quick overview about the state-of-the-art and the related work in the area of network selection, mobility management, flow management, and you can find as well all the relevant references here. And now I will going to go to the next part about introducing the different flow management mechanisms which are used in the sale. So basically, there are 4 different flow management mechanisms which has been proposed. The first one is proposed by the University of Bremen of Germany. They are trying to propose a user-centric approach, which is mainly to once you selected a number of access network, which could be 3GP and interworking with non-3GP system, and how we distribute the application flows over these selected networks. The second flow management mechanism, which is proposed by the NECTA of Australia, and this is also the approach I am mainly working on with them together, and this is a more user-centric approach, so which is mainly user-based and to consider the user-relevant criteria. So it's called a mobile driving quality experience aware network selection and flow scheduling. The third one is called access selection and decision algorithm, which is mainly proposed by University of Cantabria, mainly by the group of Professor Raymond. They're proposing the flow management mechanism to consider how to select access network and how we decide the path of transmitting certain application flows. And they are proposing a rather a general approach, which could be either user-centric or network-centric or even hybrid, so which allows them to have more possibility to interact with other mechanisms. The last one is proposed by Orange, and they're suggesting not a flow management approach, but instead they're working on the dynamic distributed mobility management. So compared to the other 3 mechanisms, the last one is only working on the mobility management, but the first 3 are more for the flow management. And as I say, the first one is for the user-centric. The second one is the first one is the network-centric approach. The second one is the user-centric approach, and the third one is flexible to have both. So each of these flow management mechanisms have different perspective, the criteria, and also this will require different informations and different enforcement to make the decision. So here we make some detailed comparisons of from different aspect for these 4 flow management mechanisms. However, I don't want to go to detail about individual perspective. The most important information I want to bring here is that we could have different individual flow management mechanisms by focusing from a different point of view. However, within the OConS framework, we want to think about the next is that once we have different flow management mechanisms, whether we can combine some of them in order to even further have a more optimized approach. So since each of the flow management mechanisms will have their benefit or advantage and disadvantage, and so the question is whether they can work together as complementary approach. So, for example, since I introduced that for example, the approach proposed by University of Canterbury is more a general approach about the network selection, and so it can be, for example, combined with the first approach. That means at the first step, using this approach to do the selection of the access network, and then afterwards we will have this selected network, and we are dealing with the problem about how we are utilizing all these selected access network. So how we distribute the application flows over these selected networks. So this is an example of we can combine these 2 mechanisms together. Another example is that the last one of the mechanism by Orange, they are proposing the mobility management mechanisms. So we can also combine this one with the mobility management in case that we firstly will select the access network, and then we're using the approach proposed by Orange to do the dynamic mobility management. So from here we can see there are opportunities and to recombine different flow management mechanisms and to let them work together. And we are hoping this could be an interesting scenario. And we are also investigating right now in the cell in this framework of orchestration. Okay, so do you have any questions for this part? If not, I will now go for the introduction of the user-centric flow management approach, which is actually the second one proposed by Nikta. So, as I mentioned earlier, the user-centric flow management approach is more considering the requirement of the users, and also in this case, the user is the one who makes the decision on the access network selection and distribution of the application flows. And the criteria are mainly user relevant. So for example, you will consider about the application quality of different application flows, and the power consumption, the application quality, and the cost. And since each user has only a partial view of his environment, so at the end, the user-centric approach is more a selfish approach, because each user is only trying to maximize its own benefit by exploiting the multiple interfaces or access links. So how this approach works? So this approach is user-centric and also taking consideration of the quality of the application flows. So the main idea of the flow management is to combine the problem of network selection and then how we distribute the flows among the selected networks. And in addition, it also proposes the cross-layer issue, which is suggesting the optimal parameter of the application or protocol parameters to adapt them according to the network situations. So in order to make the decision, we will consider 3 user-centric criteria. First one is the application quality, which is also called the quality of experience, and the mobile resource use in terms of the battery of the user device and the price of the network usage. So with these three criteria, we can define what would be the best network selection and how we're going to distribute the flow over these networks. And one important aspect that in this proposed approach, we are looking at the application quality experience rather than on only the network quality of service. Because we find out that the user quality experience is not linear related to the available network quality services. For example, in this picture you see the video quality in terms of the MOS is not linear increased over different increased available network capacity. For example, when you're choosing codec of 400 kilobit per second, and you will see that wherever your available network capacity is greater than 400 kilobit per second, your quality experience is not increased further. So due to this non-linear relation between the application quality with the network quality of service, we suggest to use the quality experience-based approach instead of using the quality of service-based approach, because we argue the quality of service-based decision would not necessarily lead to a best user performance. So keep that in mind. Then this is how we implement the flow management approach by considering the user-centric criteria. So given a number of applications, for example, you could have a voice application, you have video application, and you have a number of web flow application. And then the user device could also have multiple interfaces, and which is able to connect to different access networks. And for each of the application flow, we can also think about a set of application parameters. For example, for the video service, we could choose different video codec. So with this input, the flow management mechanism we're proposing is to decide what would be the best network to interface association. So it means for this interface, what kind of access network we are going to choose. And secondly, for one application flow, what would be the most suitable access network to select. And furthermore, for transmitting one application flow, for example, the video flow, what would be the best suitable application parameter? So in terms of what kind of coder we can use for transmitting these video services. So this is the outcome of the flow management decision. In order to do that, we are trying to focusing on the three objectives. The first objective is to maximize the overall quality of experience of all the application flows. And the second objective is to minimize the total power usage of the user device. The last objective to minimize the overall network cost. So that means once the user transmitting one of the application flow, you need to select an appropriate access network by considering to choosing the proper parameter in order to achieve the best quality experience, and at the same time also trying to choose the appropriate network in a way to minimize the network cost and the power consumption. So to do that, we will also need to estimate for one application flow to use one of the access technology, what would be the corresponding power consumption, what would be the result cost. So with those information, we formulate our flow management problem, and we are evaluate the flow management in order to achieve these three objectives. So one of the example scenario we can think about is a combined LTE and wireless LAN network environment. So in this case, the mobile node on the one hand is connecting to the LTE network while the LTE node B, and on the other hand, the mobile node is connecting to the wireless LAN while the wireless LAN access point. So the mobile node is able to communicate with the corresponding node via these two possible access networks. So our flow management approach is trying to make the decision about what kind of access network we're going to select and how we distribute the application flow over these two paths, and what kind of application parameter we are going to choose for transmitting certain application flows in order to meet the three objectives, which is the maximized quality experience, minimized network cost, and minimized power consumption of the mobile device. So that's the main idea of our proposed user-centric flow management approach. And in the framework of the OConS, we can map our mechanism on the OConS architecture. So as you have learned as well from the first part by Professor Anders, that the OConS architecture defines the three elementary building block, which is the information entity, decision entity, and enforcement entity. So in order to enforce the flow management, in this case, since we are working with a user-centric approach, so therefore the decision entity is located at the user device. So in order to make the decision, firstly, the mobile node will need to collect the information from the other network entities, like from the base station or from the wireless LAN access point, and to collect the information, for example, the link quality, the network available capacity, and so on. And with the collecting information, the decision is made, and then the outcome of the decision will be put to the enforcement entity, which is to execute the decision in terms of how you associate the interface to a certain network, and how you distribute the application flow by choosing the different network capacities according to different technologies. And also in the user device, you can also have the enforcement for each application flow, what kind of parameter or transport protocol parameters you are going to choose for transmitting these application flows. So, and this enforcement entity will be done on, for the uplink case, will be done by the mobile node, and in the downlink situation will be performed by the PDN gateway. So now you have learned about the concept about the flow management mechanism, and now it's how we are going to implement it. So given a network situation with current existing flows which are associated to certain interfaces and distributed to certain networks, and we are going to evaluate firstly by the method of using the constraint optimization problem. And the second method we are using is to using the linear programming technique, and then evaluate with the simulations. So in the following, I will give a little more detail. So by using the first method, we formulate the flow management approach as a constraint optimization problem using the mini-zinc programming language. And in this case, we take the input and we implement as the constraint optimization problem, and we get the output of the decision, and we will evaluate it by putting the result outcome to the ITUT-defined quality experience model, and with that we can calculate what will be the estimate quality of experience, what will be the consumed power, and what will be the network cost. So I will skip the detail of the implementation, but just show you what will be the gain of using our proposed flow management approach. So we compare the user-centric flow management approach with the other two commonly used decision mechanisms. One is called the network selection approach, which is actually to select a single network with the highest capacity, which is mainly the mechanism used nowadays in a lot of smartphones. The second mechanism is the load balancing. That means we distribute application flow in such a way that each of the interfaces is equally loaded. So as you can see, we compare the obtained quality experience of these three approaches, and as well the battery consumption and the network cost. So as you can see, our proposed algorithm can outperform the other two, but with a higher quality experience and with a reasonably low battery consumption, and also with very low cost. So from this result, we can see there are very big potential of again using the proposed flow management algorithm compared to the other two mechanisms. However, because we're using this, we formulate the problem as a constraint optimization problem. There's three issues of this method. Firstly, it is not an offline. It is an offline approach because we only take the input once and we evaluate the solution, and it's not able to be used in a dynamic system. And the second problem is the long solving times by using this method. And as well, the evaluation of the solution is ideal outcome, which is more or less the upper bound of the solution. So in order to solve these issues, and we're suggesting the second method by using the linear programming technique. So we hope with this method we can reduce the solving time, and we implement this as well in a simulation environment, and then we can have an online decision approach. So that's how we're doing with the linear programming technique. So now we firstly define the following notations. Here are the parameters we define for the available set of networks, the available set of interfaces, the set of the transmitting application flows per user, and also for each application flow, we also define a set of application flow parameters. For example, for one video service, we will have a number of different video codecs. So this is the input a given scenario, and then in addition, we also describe the network of different, the quality of service of different access network. One is the capacity of the given link. The other is the experienced delay of this access link. And then to evaluate the user performance, we also introduce the following parameters. The first two ones are describing the energy consumption in terms of the how much time this network is selected, and how much is the capacity which is used in this technology. And these two parameters are describing the cost by using certain access network, which also have the component of how much time it is using this network and how much of the capacity it takes from this access network. And the last parameter is defining the quality of experience of the user for transmitting one application flow. So as you can see, this quality experience is a function of the flow of the chosen capacity for transmitting this application flow, and then the experience link quality of service in terms of the capacity and available capacity of the network and the delay of the corresponding link. So with this information, we are able to estimate what could be the quality experience of this user. So with this problem, we can introduce one variable which is defined as XFCIN, which is a binary value which defines the association of one flow to using a network configuration C and distribute it to a link between the interface I and the network N. So if this flow is using this link with this configuration, then it will be equal to 1. Otherwise, it will be equal to 0. So then we can see when we have this number of flows, this number of parameters and per flow, and we have this number of interfaces and this number of the networks, we will have F multiplied by C by I by N, so such a complex problem space. Okay, so here we are showing you the to solve the flow management problem, we need to further define our objective. So this is the objective function for the linear programming. As you can see, the first part is the quality of experience of all the flows, and the second part is the consumed power and the cost, which are depending on the capacity. So how much capacity you will take per flow by using certain access network. And this part is mainly the power and cost consumption, which based only on the time. So and when you optimize them together, so we will have to satisfy the objective of maximize the cost experience, minimize the power and cost, once by time, once by the capacity, once by the time. Okay, in order to also define the relation of the time-based parameters, and we introduced the addition variable, which is the AIN, which describes the association between one link of interface I connect to the network N. So in order to play around with the priority of different metrics, we also define the parameter alpha, beta, and gamma to give the weight of the priority between the quality experience, the energy, and the cost. So these are the additional constraints we have to introduce to solve the flow management problem. So the constraints are mainly to give the limitation of one flow is only associated to one network with one interface and with one configuration parameter. And then the second constraint is to limit the sum of all the flows with different capacity. They should not exceed the capacity of the link. And then additional constraints are mainly to describe the association of between the interface and the network. So there are a lot of mathematical formulations, but in principle, that in order to solve the flow management problem, we first need to define the objective function, and then we also need to define the corresponding constraint to solve the solutions. So as you can also see that the quality experience actually is not a linear function, as I also showed at the beginning. So how we to address this problem? So we propose in this case that we will define another variable, which is called UFCIN, which is to calculate the utility of maximize the QE and minimize the power and cost related to only the capacity. And this will be pre-computed. So with this pre-computation, we will create such a lookup table, which defines that for one flow with a link between interface I and network N, and with certain configuration of the application flow parameters, and by assigning to this link with this link capacity and this delay, we will get this quality experience, and we will get this consumption of the battery, and this cost related to the chosen capacity. So with this lookup table, we can compute the utility in advance, and then at the end we are able to solve it with a linear programming, because this will be a linear problem. So in this case, we also introduced the last objective to minimize the power and cost which are relevant to the time. So as you can compare here with the initial objective function, so we do some reformulation, but at the end they are the same, they are equal objectives. I'd like to continue with the evaluation of the flow management approach. So just now I have presented you the mathematical formulation with linear programming to formulate the proposed user-centric flow management approach. So now I'm going to show you how we evaluate in a simulation environment. So we implement the linear programming formulation with the Cplex solver and integrate it into the OPNA-based simulation model. And in such a scenario, the mobile nodes are moving around between different access points of the wireless LAN and in the coverage of one LTE base station coverage. And in this case, the mobile nodes have the possibility to connect both network of using the LTE connection and possibly using the wireless LAN connection at the same time. And this is realized by using the extending the mobile IPv6 to support the multiple key of address and the flow management. So the started scenario is we are looking at one user who is moving between these two access points in the LTE coverage, and we studied two different scenarios. The first scenario where the user is transmitting the radio applications, and we choosing 4 different possible codecs for this video application, and the user is moving from the wireless LAN access point 1 to the wireless LAN access point 2 via the LTE network. And the second scenario is the user is only transmitting web traffic, and in this case the user is only moving inside the wireless LAN access point 1, and in this case the user has the possibility to connect both wireless LAN and the LTE networks at the same time. So in order to estimate the power consumption and the network cost, we given such a configuration for the power consumption and price per technology. And in this case, you can see we are assuming the cost for using the wireless LAN is for free. And however, for using the LTE network, we need to pay a little cost based on how much of the capacity is taken from using the LTE network. So with such a scenario, we are firstly looking at the video application scenario. Here we compare our proposed user-centric approach with the traditional method of 3GPP handover, which means to always using the wireless LAN whenever it is available. So by comparing these two approaches, we can see that our proposed user-centric approach can achieve less end-to-end application delay, and at the same time also have achieved less application loss, and in turn we get a bit higher quality experience. And due to our mechanism also dealing with adjusting the application parameters, which is also outcome of the flow management decision. So by comparing to the 3GP hangover approach, we can see our approach is able to reduce the overall bit rate. So in the case of when the network has only limited resources, our approach is able to adapt the application parameter in order to avoid the congestion in the network. However, the improvement of the quality experience is also paid with the cost of a bit higher of the battery consumption compared to the 3P hangover approach, and a slightly increase of the cost of selecting both LTE and wireless LAN networks. So in the second scenario of the web traffic, we also compared both approach. We find out with the web application, our approach is also able to achieve less downloading time, and in turn we can get a bit higher quality experience. And in this case, we have estimated the quality experience by looking at two different expectations. One is using the 3 seconds, and the other is the 50 seconds, which are the expected duration of downloading this web application. So we can see by choosing different expected value, we will get different values of quality experience. So this give us as well future work to do, that how we are selecting the appropriate expectation value for the user, which will have a big impact on the overall quality experience. In addition, we can also see our proposed approach has quite a lot of improvement in the battery consumption in this case, because in this scenario, the user have both connection of using wireless LAN and LTE network. And due to the behavior of the web traffic, which is an on and off period, our proposed approach also can suggest to switch off using the connections when it's not needed. However, in the traditional way, the connection will be always active. And in that case, the power consumption will be higher than the one we are suggesting. And however, this also will be paid with higher cost by using our approach, because in this scenario, the user is able to using both LTE network and the wireless LAN, and then since we know the LTE, using the LTE network, you will also need to pay a little bit higher cost, and while in the traditional approach, they will only using the wireless LAN, which is for free. So then in this case, we will gain the quality experience improvement, and also with lower battery consumption, but we need to pay for a little bit cost. So you can see in both examples, by evaluating our flow management approach, we will gain in the performance of the user application quality, but we also need to think about the trade-off, how much cost you want to pay, and how is the battery consumption will be taken by the user device. So in addition, we also try to measure how is the solving time by using the linear programming technique. And the solving time in this case is the time needed by the simplex solver to calculate for one iteration of making the decision about the network selection, flow distribution, and the application parameter for each application flow. So the solving time is a function of the problem size. The problem size is determined mainly by how many number of constraints and the variables you would define, which I mentioned in the linear programming formulation. For each of the flow, each of the interface, so for each of the application parameter per flow, we need to define the corresponding variables, and this is the size of our problem. So with increased problem size, we will have increased solving time. But with the given example scenario, we find out that our solving time by using the linear programming technique is reasonably efficient. So the maximum time we take in this example is only 390 milliseconds. So this gives us a very good message that by using the linear programming technique, we improve a lot about the computation time, and this allows us to also implement such an algorithm with an online approach in a real system. So to summarize, what is the user-centric quality-aware management approach we are proposing? This approach is trying to maximize the quality experience of all the application flows of the user device and minimize the total power consumption and the total network cost. And we try to formulate the problem with two different methods. The first method we formulate as a constraint optimization problem, and we compare with the two other decision mechanisms, and we find out the proposed flow management mechanism can outperform than the other two mechanisms by higher application quality and with reduced power consumption and reduced network cost. And this is the gain of our proposal. And in order to implement this mechanism in our online approach and with a dynamic system, and we formulate the problem with linear programming by defining it as a binary integer problem, and we implement the formulation using simplex in the simulation environment, and our investigation result from the simulation has shown that there is improvement about the quality experience for the user, and however we might have to think about the trade-off between the cost and the power consumption. And another messenger we get is that from the investigation we find out applying the linear programming technique is very well suited for the online approach, and it's very feasible for us to make even the real-time decisions in the real systems. Okay, this is the part for the scientific analysis of the flow management approach.